Okay, so question 11 on our mean value theorem circuit has a function of 2e to the x, and between 0 and natural log of 5 we are supposed to find where the mean value theorem applies. So first, mean value theorem, the part that you need to keep reinforcing in your head is that mean value theorem says that instantaneous rate of change, which is derivative, this derivative just happened to be the same thing, is equal to the average rate of change, which is like slope formula, at least once, as long as it's continuous and differentiable between these two numbers, which it is. So over here we've got 2e to the x. Some of this is a little easier than others, but this is natural log of 5. F of 0, if we plug in 0, what do we get? Because anything to the 0 power is 1. Okay, and then I'm going to box this in. If I plug in natural log of 5, I get 2 times e to the natural log of 5. And now one reason I really like these circuits is because each question throws a different thing at you. There's probably only one question where you really need unit circle a lot. There's probably one question that's a piecewise function. This just happens to be the question that forces you to try to remember logarithm properties. So do you remember in a logarithm when you have a number and its exponent is log base of the same thing? Do you remember how that simplifies? Does anybody remember that? Right, it just ends up being whatever you're taking the log of. So I know you see that in Algebra 2 and Pre-Cal, but you don't ever see a use for it, so it just doesn't stick as much. But that's what's happening here. E to the log base e of 5, this all goes to 5. That's just one of those 10 logarithm properties that we don't use often, so we don't remember them very much. But they do put stuff like that on the AP exam, so that's what we have to review throughout the year. So this ends up being 10. 2 times 5 is 10. Okay, so we got 2e to the x is equal to 8 over the natural log of 5. So what's one thing that we could do to solve this for x? How do you get rid of this times 2?
Divide by 2.
Okay, and then I can reduce this. 8 over 2 would be 4. Okay, so we needed this logarithm property to help us evaluate. So you will see that again at some point. I'm not saying this like on this next test or anything, but it will show up again. So if you don't know that, add it to your list of things to study. But the other logarithm property you need here is to understand that logarithms are the only way to solve for an exponent that's in the, a variable that's in the exponent. So the trick here is to take the natural log of both sides. In calculus, we just always use natural log. And then this is helpful because if you're taking the log of something that has an exponent, that exponent can come down out front. That's the only algebra property that we have that gets a variable out of the exponent. What about the natural log of e? Because this is saying e to what power gives you e. So I guess that's technically a logarithm property also. But so it looks like our answer should be the natural log of 4 over the natural log of 5. Which is kind of a messy answer, but it does match up with one of them. Okay, is that all you needed there? So I'm highlighting the 3 things that I think that you guys have likely to have gotten stuck on that question. Solving for a variable in the exponent, consider taking the natural log of both sides. Know that the natural log of v is 1. It's helpful to know why, but that comes up a lot. And then this logarithm property is not common, but it is certainly expected that you have learned that at some point. So again, put that at the top of the page, put that on a separate sheet of paper. It's not like it's super pressing, but you do need to know it before the AP exam.